and let's get started. So, pop quiz, we said it earlier. Everybody, percent means out of what? Hit me in the chat box. Go. Percent means out of what? That is correct, everybody. 100. And so that's probably going to be one of the easier questions we might have today. Only going to get harder from here. But still, percent means out of 100. And it comes from the word. When you think about the word percent, per means for every, cent, think about it. How many cents are in a dollar? 100. So out of every 100, that's what percent really means when you translate it from the actual word. Percent means out of 100. And so let's go ahead and get through the absolute basics here. These are too important, these fundamentals that we're going to go through. First off, how to find the percent of a number. Basically, everybody in math, when you see the word of, what operation does that typically tell us? The word of. Exactly. Multiply. Typically, it's going to mean multiply. And by typically, I mean like all the dang time. And so, yeah. So when you're finding the percent of a number, you're taking that percent and you're multiplying it by that number. Again, the word of, it's going to mean multiply. And so when you take a look at the example that I've got for y'all here, before you multiply, make sure that you always convert that percent to a decimal. And so what you really need to do here, the shortcut version of it, is just divide by 100, which is basically moving 2 decimal places to the left. So if we're taking a look at this example right here, 50% of 20. Well, 50%, to turn that into a decimal, we move that 2 spaces to the left. Let me just go ahead and zoom in for y'all right there. You're going to take that decimal 1, 2, and you'll move it to the left twice. And that's how you see it right here. Now, I want to pause for a moment and ask everybody why that is. Again, today is all about really building that confidence through those fundamentals. So everybody, why is it that we move the decimal place over 2 times? You can go ahead and raise your hand if you want me to call on you on the mic, or you can type it in the chat box. But I'm not moving on until we get this one. Why is it that we move the decimal place 2 times to the left? Any ideas? Well, that was quick. Yep. Sile basically just got everybody for you. So yeah, exactly. Sile says, and Sile is King Arsenal. It's over 100. So yes or no? You guys remember how we said percent is out of 100? Think about it. If you divide by 10, you move the decimal place once. Divide by 100, you move the decimal place twice. Yes or no? Does that make sense? Yes or no? Great job, Sal. Great job, man. Right on, right on. Yep, exactly. So right there again, we move the decimal place 2 times to the left. So I'm going to go ahead and write it over here because we're dividing by 100. Because we're dividing by 100. That's exactly why, right? You move the decimal place twice to the left because you're dividing by 100. And so this is going to come back later in class when we start talking about going from decimals back to percents. Because think about it like this. If we're going from a decimal back to a percent, what direction might we be going when moving those decimals? Right on, Kalia. First one there. Yeah, we're moving back to the right. Because if we're going backwards instead of going left, we're going to go to the right. So we're going to keep looking at these little pieces of information for sure. But let's take a look at the example here. So 50% of 20, that's going to be the same as saying 0.5 multiplied by 20. And that's going to give us 10. But to show you the math and how it works, really you would just go ahead and take 20. You would multiply it by 0.50. But let's go ahead and ask ourselves real quick, to give ourselves an easier time, everybody, can we multiply by 0.50 or can we multiply by something else to make our lives easier? Marquette, shout out. We can just multiply, oh, not 50, just 0.5, just 0.5. Because everybody, is it fair to say that 0.5 5 is the same thing as 0.50, same thing as 0.5000. Aren't they all the same? Aren't the zeros after a decimal place just irrelevant if we want them to be? Exactly. They are absolutely irrelevant. These are all the same. You can even add like 17 zeros if you want. You can add as many as you want. I'm guessing that that's 17. Don't count. Don't embarrass me. But yeah, any zeros after the last actual digit in a decimal don't matter. And so to give yourself an easier time, knowing that when you multiply, you're going to have to create more rows, don't do that. Don't do that. You can just go ahead and get rid of that 5 right there, and you can just multiply by 0.5. That's all I'm saying there. Because now, when we do the math here, let's take care of it. So we have 0 multiplied by 5. That's going to be 0. Then we have 2 multiplied by 5. That's going to give me 10. Now, everybody, what do we do with that decimal right here? What do we do with that decimal that's on that 0.5? Right, we carry it back. We carry it back. And so if there's one decimal place that's removed in that problem, we will move that decimal place back. And that's how we get 10 as the answer. That's how we get 10 as the answer. Now, let's go ahead and have a little survey real quick. Anybody here already knew this? So type in knew it if I already knew this front to back, or say that, just say this was good, as in you learned something. So knew it or learned something new. I want to see where we're at with that. Because I can expect the majority of us saying, I knew it. That's cool, because I know a lot of us here have been to my classes before. But I want to make sure that no one's left behind here. We're all on the same page moving forward. All right, cool. Sounds good. So with that said, my party people, with that said, there it is right there. I'm going to give you guys an extra 5 seconds. Take a quick photo if you need to, or a quick screenshot if you'd like to go ahead and just, kind of listen to me as opposed to trying to scramble and take notes. So I always give you guys the opportunity to take notes. And for those of you guys who are in the All Access program, of course, you're going to see this recording in your library tomorrow morning. So with that said, 3, 2, let's go ahead and go to the next one. So this one, I want you to take grab a quick screen capture of this really quick. Just take a quick screenshot. Really what I want to say about this is really pushing the idea that there's more than one way to do math. I know a lot of the times in high school, especially, the teacher doesn't have all the time in the world to teach you the different ways to do things. So I want you to really pay attention here. Yeah, you can follow the formula of doing the percent of the number equals the result. Multiply them and you get the result. Cool. But not a lot of people know this part right here. When you think about percents, everybody, to be honest, remember earlier how I said percents are ratios? Yeah, you can set up a percent problem like a proportion if you'd like to. Now, is this always going to be the best way to go about it? No. I mean, it'll still get you the same answer, same method, but this will only help you see some mental math tricks if you are already at the point where you practice those little fundamentals. And so whenever it becomes appropriate, I will bring this second one up to really show you. But long story short, you got to know these right here, green and red. So basically, here's the trick that I want to teach everybody in terms of keeping a sane mind whenever you're doing new problems. So forward, you're going forward when they're asking you to find the result. Because everybody, how do you find the result? By moving forward, right? And so the forward way to find a result, you're always multiplying the percent, always multiplying. However, when you're working backwards, let's go ahead and say they give you one of those problems like, hey, 15% of what is 140? Well, in that case, you got to go backwards because they already gave you the result. And so you have to divide, not multiply. And so this is something that we really want to make sure we take down here. The forward and backward thing, honestly, I'm going to drill you guys on this today. We're going to make sure we have this down by the end of class. And I'm really excited to see it. So again, forward, multiplying, and that's again to find the result. Backwards, to try to find the original number or find the percent, we're always dividing. Always dividing. All right. So once you got that down, type got it in the chat box. I'm going to give you an extra 30 seconds and we're going to start with some warm-up problems. And again, you can always take a screenshot if you don't want to risk risk missing out on what I'm saying. Cool. A couple more moments there. Man, I'm excited for today, though. Gonna have a lot of good drill sets. All right, let's go ahead and keep moving forward here. What's up, Menahem? I'm gonna go ahead and give you the mic there. What's up? What's your question? Going once, going twice. Go ahead and type your question and I will get to it. I got you. Hey, what's up, Jacob? This is gonna be 2 hours today. So let's go ahead and get to, so we're ending at 8 p.m. Eastern. So we have about an hour and a half. Yeah, so the first half hour, typically we're going over notes. And then the rest of the time, like you see here, practice, 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 practice. So let's go ahead and get to it, my party people. So starting with the top left over here, I'm going to give you an extra 5 seconds to write down more problems if you feel pretty confident right now. But even if you're feeling super confident, you're going to want to stay till the end. I got you. So I'm going to zoom in now. And we're going to start here with 3% of 64. So let's go over this the straightforward way. Everybody, if we're doing 3% of 64, one more time, the word of means that we're going to do what? The word of means multiply. Remember, of, that's multiply. When we see out of, that's going to be divide. All right, that's going to be division. Just want to make sure that everybody sees that. So of means multiply, out of means divide. And so what we have here is 3% of 64. So everybody, what is that 3% going to turn into? Yep, exactly. Because every time we move every time we go from a percent to a decimal, we're going to move that decimal place 2 places to the left. Exactly. 2 places to the left. And so if you're having any trouble seeing it, I know sometimes people might think that it's going to be 0.3, but that is not the case. Because when you think about it, let's just have a 3 right there. If I take that decimal place and move it over 1 time, that's 0.3. I got to move it over again right here, and that's going to give me 0.03. So for those of us that put 0.3, do we see why it's 0.03? Want to make sure we see that. Really got to make sure we see that there. Perfect. Sounds good. Karen, Eduardo, Lizzie, appreciate that. So let me go ahead and write this out here, 0.03 with a consistent color. Again, and that's because, again, let me just write it over here. 1, 2. So we're going to have a decimal, 0.03. Exactly. It's out of 100. So 3 is like 3 cents. Exactly. Great analogy there. So now what we have here, we're going to be multiplying, again, because the word of means times. And then we're going to have that 64. So now really all that's left, gang, we're just going to go ahead and take 64, multiply by that 0.03. And then we're done. Looks like I'm using some Halloween colors today, but here we go. So everybody, quick, 4 times 3 gives me, help me. Let's go. A lot of you already have the answer right on. So it's going to be 12, carry the 1. 6 times 3 is 18. Carry that 1. That's going to be 19. So we have 192. But what must we do now, everybody? What must we do now? Type it out. Use a full sentence. Don't be a cheapskate. Move the decimal how many times, Eduardo? Let's be specific here. Let's be specific. Twice. Yeah, we got to move it twice here because, again, we had it moved twice over here. So let me zoom back in. We had it moved twice back there. So we're going to bring it back twice here. We're going to have 1.92. Right there. Right there. And so with that said, my party people, the answer to this first one is going to be 1.92. So allow me to just make this a little bigger for anybody who needs to see that. Now, let's go ahead and take care of 31% of 24. Let's go and take care of that one over here at the top right. Let's get it. Zooming on in nice and slow. 31% of 24. Let's go ahead and go through our motions again. Everybody, that 31% is going to turn into what? That's right. That's going to be 0.31. But pop quiz real quick. yeah, the rule says move it 2 decimal places to the left, but what are we actually doing to convert it? What are we actually doing? To all percents, to turn them into decimals, we are always, right on, Alex, dividing by 100. To convert all percents to decimals, because percents are out of 100, we're technically dividing by 100. And so for every zero that you're dividing by, so 100, 2 zeros, you move it 2 times. So you move it for every zero that you see. And so we have 0.31 multiplied by 24. And at the end of the day, gang, same concept. Just get in there, do 24 multiplied by that 0.31. And we're just going to go to work. So let's go ahead and get to it. So here, 4 times 1, that's going to go ahead and give me 4. 2 times 1, that's going to give me a 2. Nice and easy. Not much work needed, not much effort. But then, everybody, what should I always remember when I'm going into that next row of multiplication? What do I have to include again? For anybody that may have forgotten, that's right. Because when we're moving down a row, we're actually moving to the next, basically the next digit. We're moving to the 10th place now. So that's why that's necessary. And so we're back to it. 4 times 3, that's going to give you 12. Then 2 times 3 is going to give me 6. Then we carry that 1 right there, and that's going to give me a 7. So once we have that going on, we're going to add everything up. We've got 4, 4, and 7. But what must I do, everybody? What must I do? That's right. We got to move those decimal places back. We have to bring them back. And so if we notice over here, we've got 1, 2 decimal places moved. So we'll go 1, 2 back. So our final answer will be 7.44. Booyah. So on a scale of 1 to 10, how confident are we feeling right now about our ability to move forward to calculate percents? On a scale of 1 to 10, how are we feeling so far? Evelyn, can we just multiply the 31 times 24 and place the decimal where it needs to go? Absolutely, Evelyn. Yeah. And so we're going to be talking about these shortcut methods as we keep going along, for sure. But that is absolutely what you can do, because when you think about it, that decimal doesn't come in until the end every single time. And so if you wanted to do it that way, absolutely. Absolutely. So let's go ahead and move into this one here. Here we go. Hey, no worries, everyone. That's good. And Karen asks, what about 100? Does that count in terms of the moving decimals and dividing by 100? Yeah. They're the same thing, and you can do that at the end. Absolutely. Yep. So with that, moving over here to 10% of 35. So let me show you guys a nice little, again, a convenient percent to look at. Everybody, when we said 50%, there's 2 50s that can fit in 100. So 50% is the same as dividing by 2. Everybody, how many times can 10 fit into 100%? How many times can 10 fit into 100%? 10 times, right? Because 10 times 10 is 100. Okay. So if 10 can fit into 100% 10 times, that means that finding 10% is the same thing as dividing by 10. Everybody, isn't dividing by 10 pretty easy? What's 35 divided by 10? What is 35 divided by 10 going to be? Right, that's going to be 3.5. I'm going to show you exactly how to do this. Don't worry, I got you back. Don't worry, I got you back. I'm going to show you exactly how to do this here. So the answer here is going to be 3.5 because dividing by 10 is just moving the decimal place over. But allow me to show you step by step what's happening. So if we wanted to, we can go ahead and take that decimal place and do our thing. Everybody, that 10% is going to turn into 0.10, correct? Cool. And then from here, the word of means times, and we bring in that 35. Devin, I'll answer that in a moment for you. I got you, boss. So here, we got 0.10 multiplied by 35. Everybody, for the sake of simplicity, we can also write 0.10 as 0. What? For the sake of simplicity, right? 0.1, right? Exactly. We can just write 0.1. And so we'll do 0.1 multiplied by 35. Let's go ahead and check this out, guys. Let's do it. So over here, I'll go ahead and write a magical 35. Multiply that by 0.1. All right, sounds good. Let's go. 35 times 1. That's just going to be 35. And then we'll just take that decimal place and bring it back. Boom. And so we end up getting 3.5. So notice how we went through that method, the guaranteed method, but notice how we were able to use some mental math and kind of do it right away anyway. And so, hey, it's all good, Aylin. Hey, it's all good. Again, it's all about that learning process. So before I continue, I do want to answer Jose's question. Go ahead, Jose, and then we'll continue right after.
Coach, does it really matter, like on the example on the test? Can you hear me?
Yeah.
Oh, does it really matter on the test as if it's 3.5 or 3.50?
Doesn't matter. No, because 3.5 and 3.50, they're really the same thing. Typically, what you're going to see in the answer choices, they're going to give you the answers in the simplest form. So they'll typically just give you 3.5. Yeah, exactly. We're all learning here. It's all good. But good question, Jose. Good question there. So I want to show you again the reason that some of these strategies might really be useful. Because if you're looking at 50%, same thing as dividing by 2. 10%, because 10 fits into 100 10 times, you can divide by 10 when you have 10%. Everybody, I'm going to show you this next one. It's going to show you a percent. But want everybody as quickly as they can to tell me what we're actually dividing by if we use mental math. What do we see? What would we divide by here? What could we divide by here? 25%. How many times does 25 fit into 100? That's really what we're dividing by. Yeah, it's going to be 4. Exactly. It's going to be 4. If we are, let me go ahead and check this real quick. Just make sure I'm not breaking anything there. All right. When we're multiplying by 25%, or doing 25% of a number, think about it. It's out of 100. How many times does 25 or a quarter, 25 cents, fit into 100 or $1? 4 times. When you're doing 25%, it's the same thing as dividing by 4. Everybody, watch this. What is 44 divided by 4? What is that going to be? That's going to be 11. I think a lot of people here are confident about that. I would hope so, right? Yeah. 44 divided by 4, that's going to give us 11. But don't take it from me. I'm not Jesus. Let's go ahead. Let's figure this out. Let's see what happens if we actually compute 25% of 44. And let's see if this shortcut actually works. Okay? Just going to try it out here. So everybody, let's go ahead and do our mathematics here. 25%, convert that to a decimal. What's that going to be, everybody? Be careful, be careful. We got to move it 2 times here, not once. We got to move it twice. Remember, move the decimal twice. So move that decimal 2 times. And so that means from here, we're going to go 1, 2. So that's going to turn it into 0.25. Remember that, my party people. Got to make sure you get that part down, because again, if we mess that part up, even accidentally, what's going to happen is the entire answer is going to be wrong. So we got to make sure we get these setups right. So we have that going on. And then next, that of, one more time, everybody, I'm going to be annoying with it. Of means what? Of means what? Come on, come on, come on, come on, come on. There we go, there we go. Means multiply. And then we bring that 44 right back. Right there. So we have 0.25 times 44. Let's set up our mathematics here. Oh, man. Anybody here excited to do a 2-digit by 2-digit multiplication? Anybody here happy about that? Would you guys like to do that on the ASVAB all day? I mean, honestly, if that's all you had on the ASVAB, probably. But when it comes to being times, that's not something you always want to have to do. So this is where I'm teaching you, again, the idea of being able to save time. Let's go. So first and foremost, 4 times 5, it gives me 20. Carry the 2. Then we're going to have 4 times 5 again. It gives me 20. I'm going to carry that 2 right there. 20 plus 2, 22. All right. So now we're moving on to that next digit here. So let me actually write that too with a different color. That way you know I'm doing it. So now we're going to have 4 times 2. That's going to give me 8. So let me just put the 0 here, then the 8. Then we're going to have 4 times 2 again. That's going to give me 8 again. All right, sounds good. So with that said, boom, add it together. We're going to have 0, 2 plus 8, 0, carry the 1, 2 plus 8, 10, carry the 1. It's going to give me 11. All right. Now, everybody, what do we do again with those decimals? Bring it back. That's right, Jose. So we have 1, 2 decimal places, 1, 2, and our answer is 11. But think about it like this, everybody. Would it not have been more convenient to look at this and be like, oh, yeah, 25%. That's a quarter. That's just dividing by 4. Would that not have been way more convenient here? Yes or no? You tell me. Again, gang, like this is what I want to teach y'all today. This is what I want to teach y'all today. It is not just about like just surviving and learning how to do the bare minimum. It's about speed. It's about confidence. Like if you're here trying to take the ASVAB and you're going to go ahead and print out some formula sheet, then the day before you go take the ASVAB, you're like, a squared plus b squared equals c squared. I'm going to crush this. We're good. Well, guess what's going to happen tomorrow, right? You're going to be a little disappointed. It is not just about knowing the vocabulary, terms, and definitions. It's about knowing how to apply them. So let's go ahead and keep going. Let me zoom on out here. We've had 4 different problems here. And just like Evelyn pointed out earlier, you can absolutely just multiply the numbers and then move the decimal at the end. Evelyn, absolutely correct about that if you wanted to do it that way, for sure. So I'm going to answer these questions here, and then we're going to move right along. So here, Ashley asks, is it okay if I multiply 0.25 times 44 instead of the other way around? Oh, absolutely. So Ashley, to confirm that, so everybody, what Ashley is asking is, instead of doing right over here, 44 times 0.25, Ashley's asking, and let me know if I'm right in saying this, Ashley, what if I did it like this? Is that what you're asking? Yeah, cool. So Ashley's asking, can I do it that way too? And the answer, short answer is yes. You absolutely can. Because think about it like this, Ashley. What is 5 times 3? 5 times 3 is 15. If I switched it around and did 3 times 5, still 15. So absolutely, yep, you can switch the order around. Doesn't matter at all. Doesn't matter at all. Yeah, so let me know if that helps you out there. And then Janice, what if it was 25% of some crazy big number? Would the same apply? Yeah, exactly. Because if you're doing a crazy big number, like let's say it's 572,000 or whatever, dividing by 4 is still a lot faster than multiplying by 2 digits. You see what I'm saying there? Instead of multiplying by 2 digits, you can just divide by 1. And that's really what I'm saying there. So that's all the suggestions that I'm making there. Cool. Sounds good. All right. So with that said, gang, let's go ahead here. Bring it on back. And now I want to make sure that you guys have the ability here to write down these convenient percents. I want to make sure you have the chance to write down these convenient percents. Because if you're looking at 1%, well, think about it. What you want to ask yourself is, how many times does the number fit into 100? And that's the number that you can divide by instead. So because 1% out of 100, you have 100 to go, times 100 to go, just divide by 100. If you're saying 2%, well, 2 times 50 is 100. So 2% of a number is the same as dividing by 50. 4%, well, 4% times 25 gives you 100. So to find 4%, you would divide by 25. Lastly, with 5%, well, 5%, 5 goes into 120 times. So 5% of a number is the same as dividing by 20. So yes or no, does this make sense, everybody? How we can make use of these conveniences to get things done a little faster? Because that's really ultimately what I want at the end of the day. I want you guys to be able to look at this and say, okay, if I see this, I can actually save myself some time. That's what I want. All right, cool. So I've got another slide for you right here, and it's going to be more convenient percents. So everybody, what's another percent that I mentioned that's not here? That's a convenient one. What's another convenient one that I haven't mentioned yet? In this page, at least. 10% is another convenient one. Yes, give me another one. What's another one? What's another convenient one? Pierre, 20 is absolutely a convenient one. 50 is also a convenient one. There we go, Bruna. Yeah, there we go. Those are another set of convenient ones for sure. For sure. So with that, we're going to move into that slide. So take a quick picture here if you need to. Take a quick little screen capture, a little screenshot. 3, 2, and next one. And so we have a couple more convenient ones. 10%, 20%, 25%, and 50%. These are all more convenient ones as well. Please go ahead and take a screenshot, because with these, we're going to move forward again. I'm going to give you guys a chance to practice. Do I do D-Lab tutoring? I'm not quite sure what that is. Not quite sure what that is. Marquette, so 3% isn't convenient. Well, the thing is, Marquette, so once you know these basic percents, any other percent is literally just a combination of those convenient ones. So if you think about it, 1% is the same, or 3% is the same thing as 1% times 3. So what I would do is I would find 1% with my convenient, like little method there, then times 3. So that's one way you can think about it if you want to work quicker to get that done. So I'm going to give you guys 5 more seconds here to take a quick screen capture, quick screenshot. I'm going to go back up for somebody, for David, real quick. Oh, cool. That's informative. Thanks for letting me know about that. Hey, that's something I'll probably get into. That's probably something that I would enjoy doing. So I may look into it, but right now I do not offer that kind of tutoring. So quick screenshot right there. Going to give you 5 seconds for anybody else who didn't get there. 3, 2, counting longer and longer. Let's go ahead and get into it. So let's get into these warm-up problems here. I want to give y'all a whole 2.5 minutes. I want to see if you can get done as many of these as you can. Some of these have convenient percents. Some of them don't. I want to see how quickly you can work, again, with 2.5 minutes. Go. So let's go ahead. I'm going to go through these, not terribly fast, but I'm going to speed up the process just a little bit, because I'm going to go over 2 ways to do every single problem. One is the traditional way, and the other way is using mental math, using these conveniences. So watch this. So starting off with 20% of 50, one thing I would do is immediately turn that percent into a decimal. Everybody, 20% turns into 0. That's right, 0.20 or 0.2. 0.2 is a little more convenient just because, again, you're dealing with less digits. When you're multiplying, less digits is typically going to be better. So there we are. We got 0.2. So what we're going to do here is do 150 times 0.2. And we're just going to get to it. 0 times 2, 0. 5 times 2, 10. Carry the 1. 1 times 2 is 2. Carry the 1 gives us a 3. So since we moved that decimal place over 1 time over here, we'll bring it back 1 time, and our answer is 30. So again, the straightforward way, turn the percent to a decimal, multiply, and you're done. But remember, on the ASVAB, if we can notice some conveniences, we're in a pretty good spot. So what did I say in our notes, everybody? 20% of a number is the same thing as dividing by what? It's not going to be 4, because 4 is going to be 25%. When you're doing 20%, that's the same thing as dividing by 5. Exactly. No, you're good. Again, mistakes happen. Multiplying by 5, that's what it's going to be. Because remember, because 20%, because when you multiply it by 5, that's going to give you 100%. Well, that means that to go from 100%, which is, again, the original number, back to that 20%, we're dividing by 5. And so that's what's happening here. And so now what we're going to do is, to make life easy, we can just say, hey, what's 150 divided by 5? Because again, this is 20%. That's what 20% is. It's just dividing by 5. Everybody, that looks pretty convenient. What's 15 divided by 5, everybody? 3. 15 divided by 5 is 3. And because there's a 0 next to that 15, 150, it's not going to be 3. The answer is going to be 30. So anybody like that right there? Pretty convenient or not? Right? Pretty straightforward there, right? Pretty straightforward. So before I continue, Christian, go ahead, boss. I got you.
So one thing that's always helped me was you might have already mentioned this, I came in class late, but for every 10, 20% is 2. So for every 10 there's 2.
Mm-hmm. Yeah, I'm going to dive into that one as well now. So the one thing I'm starting off with, you might have missed this, where I was going through the convenient percents.
Right.
And now we're going to start going off into playing off of those convenient percents, just like you're talking about, to go from 10%, double that to get to 20.
Right.
Because watch this, everybody. If I were to do 10%, 10% is the same thing as dividing by what, everybody? 10% is the same thing as dividing by what? If I'm doing 10%. Right, 10% would be the same thing as dividing by 10. Think about it. 10 can go into 100 10 times, and I can show you right here. Right here. 10%, same thing as dividing by 10. Same thing. And so when you think about it, everybody, what's 150 divided by 10, everybody? What is it? $10 of 150 is going to be 15, because if you're doing 10%, that's dividing by 10. But everybody, the question did not ask us to find 10%. It asked us to find 20%. Everybody, what do we do if we accidentally found 10%? What could we easily do to jump up to 20? What could we do? Exactly, double it. If we have 10%, but we're supposed to have 20%, double it. If you double 10, you get 20 and you're good. And so that's exactly what you can do. You can just say, hey, look, times 2, that's 20%. And that's going to equal, multiply by 2. Everybody, 15 times 2 is 30. Another way to think about it. And so when you have that right there, you're feeling pretty good. But again, today's class is about confidence through understanding. There's not just one way to do math. There's plenty of different ways. And the way that you pick, the way that you ultimately come down to saying, hey, I'm confident with this, that's what I'll be proud of. All right. So Jose, quick question, and we're moving forward.
Coach, I was going to ask you, how can you convert like 20 and stuff like that to dollars? Because I understand the 50 and the 25, because you mean the 25 to make $1, 4 quarters, 50s too. I understand that. But how do you do like 24 and 15? How would you do that?
Well, when you think about it, so if you're doing 10%, well, how many dimes in $1? 10 dimes. And so you can say that's a 10 divided by 10. To do 20, you can say that, well, how many times, again, how many times does this number fit into 100? And so if you're talking 25, what's a quarter? That's 4 times.
Yeah.
Saying 20%, well, 20, 40, 60, 80, 100, 5 times. So divide by 5.
No, I see.
Yeah. And so with practice, through and through, we'll definitely get more and more confident as time goes on, for sure.
Okay.
For sure.
Thank you.
Hey, not a problem. And so if we're looking at 4% of 725, everybody, we can go through this 2 ways. One way is going to be by saying, hey, we have 0.04 multiplied by 725. Or the other way that you might see it could be 725 divided by what, everybody? Divided by what? Mario, good job. Not a shortcut way, but depending on how you look at it, one might be shorter than the other. And so this is why it's important to know both ways, because everybody, which way is probably faster? The multiplying way or the division way? Which way is going to be faster in this case, in your opinion? Some people say division, some people say multiplying. In my opinion, in this case, I would say multiplying might be a little faster here. Multiplying might be a little faster. But again, to each their own. Let's go ahead and figure this out here. So 725 multiplied by 0.04. Let's get to it here. Right there, 0.04. And let's go. So 5 multiplied by 4, that's going to give us 20. Then 2 multiplied by 4, that's going to give us 8. Carry that 2, it's going to give us 10. And then over here, 7 times 4, that's going to give us 28. Carry that 1, and we get 29. So because we moved that decimal place twice for that 0.04, what will we do now? Go. Because we moved that decimal place over, now we got to move it back. That is right. That is right. So once, twice, making our answer 29. Right there. Right there. And so boom, we got 29. And now if we look at 725 divided by 25, again, dividing by 25 is the same thing as multiplying by 0.04 or 4%. Same thing. But if you look at that, you might be looking at that like, might be a little more work. But let's go ahead and get to it. So 25 divided into 725. Everybody, how many times does 25 go into 72? 72. Twice. 25, 50. If you do 75, it's too much. 75 is bigger than 72. So just 25, 50. That's how it's going to be there. And so we've got 2, and we'll take away 50 right here, drop it down to give us 22. Bring that 5 down. And now we're saying, hey, 25 goes into 225. How many times? And how many times is that going to be? 9, and that's probably going to be some guesstimation there. 25, 50, 75, 100. 125, 150, 175, 200, 225. 9. Okay. So you might need to use your fingers there, and that might take might take a second, but we'll still get the same exact answer. We'll still get the same exact answer. So which one might have been faster now at this point, everybody? Anybody here change their mind saying that, okay, multiplication is probably faster in this case? Yeah, cool. Glad to see it. I'm glad to see it. So here we go. We're going to speed up the process just a little bit now. We're going to get to 15, 50, 2%, and 30%. I'm going to start right here with 50%. Everybody, the answer here is going to be 240. That's the answer. 50% is the same thing as dividing by 2. Same thing as dividing by 2. So we'll do 480 divide by 2, and that's going to equal 240. So in this case, the convenient way, just divide. If we take a look at 15% here, well, the thing is, think of it like this, everybody. If I wanted to do, so the answer here, what it's going to be 27. So let me actually just make sure I give you the answer. The answer is 27 here. But I want to make sure everybody really sees these mental math tricks. I got to make sure you see them. So everybody, is 15% the same thing as 10% and 5% added together? Is 15% the same thing as these two added together? Yes or no? So this is another rich way that I really want to, give you an idea of if you haven't seen it this way. Because everybody, what would 10% of 180 be? If we're doing 10%, that's dividing by 10. So what would 180, 10% of that, what would that be? What would that be? Can we all see that it's 18, right? It's 18. Yeah, exactly. If we're doing 10%, that's going to be 18. Everybody, isn't 5 just half of 10? Yes or no? Isn't 5 just half of 10? And to answer your question, no, you won't see it. Not in that form, Mario. Not in that format. That's a misleading format. And if they did go that way, I wouldn't even take that test seriously. They're just trying to give you a bunch of trick questions. So yeah, 10% is just dividing by 10. And then if you have 10% and you need to go to 5%, that's just half of it. So everybody, isn't 5% going to be half of 18? Isn't that just going to be 9? That's just going to be 9, right? Yeah. So when you think about it, if I go ahead and add the 10% and 5% or the 18 and the 9, isn't 18 plus 9 going to be 27? And I'm just using mental math here. If I know that 10% is 18 and I got to get 15%, so 5% more, well, half of that 10%, half of that 18, that's going to be 9. So 18 plus 9, 27. Done. Did that make sense to anybody out there? That mental math way? Because again, we can do it the straight up way. You'll still get 27. You'll still get 27. Absolutely. But I want to see if we can really appreciate these different methods. So Kalia asks, I'm not understanding how you got 270. I thought you moved the decimal 2 times. So how do we get to 70? I got 27. Got 27. It wasn't 270. And then is that something we do a lot for other problems? Absolutely, Kendra. Absolutely. Absolutely. And so Marquette, so let's go ahead and answer that one there. Sounds good, Kendra. So Marquette says, hey, I'm confused on the last one. I got 24, not 240. Everybody, if we move that decimal place over 2 times, we will get 0.5, right? And that's the same thing as 0.50, 0.5, all good either way. But when you multiply, you got to make sure that if you're doing the 0.50, so I'm doing for this problem right here, if you're doing the 0.50, you got to make sure that you do both layers here, both layers. That's why I really suggest taking that 0 out because it's not even necessary, which is going to give you an easier time because you'll end up getting 2400 and you'll only move the decimal place 1 time back. So Marquette, that's likely going to be the reason why that you got 24 because you might have moved it over an extra time, which wouldn't have been necessary there, which wouldn't have been necessary. Cool, Adria, that made sense for you too. Perfect. Nelia, perfect. Marquette, there we go. Sounds good. And so again, 50% is half. 50% is halfway. 2% here of 36. Everybody, the answer here is going to be 0.72. This is what the answer is going to be here, 0.72. Here's how we get there. So what we can do here is find out what 1% of 36 is and just multiply it by 2. So let me go with a straightforward way before I go back to the mental math way. If I do 2%, that's 0.02 right there. What do we do next? We'll take the 36. We'll multiply it by 0.02. And we'll go ahead and move forward. So here, 6 multiplied by 2 gives me 12. 3 multiplied by 2 gives me 6. Bring that 1 back, we get 7. And since we did have that decimal moving 2 times over here, we will bring it back 2 times right there, 0.72. So we can still get that same answer again, going straight forward. But remind me, everybody, if I want to get to 2%, we can think about that with mental math. That is the same thing as 1% doubled up times 2. Everybody help me out in the chat box. 1% is the same thing as dividing by what? Same thing as dividing by 100, exactly. If I wanted to find this a little quicker, just a little quicker, we could actually do this with 1% and then multiply it by 2. So if I did 1% of 36, everybody, what's 1% of 36? What is that going to be? 1% of 36. Devin, I believe you meant a decimal place. 0.36, right? That'd be 0.36. And so if we just doubled up to get 2%, this is happening in your head, you can really think about it like this. Like you are allowed to be creative in math. You're allowed to be creative in math. And so I got to ask everybody, if I did it that way, just saying, hey, what's 36 times 2? Okay, 72, 0.72. Would that make sense to anybody if I presented it that way? Like, obviously going through the first way first, But would this make sense to anybody if I did it that way too? Where you can find 1%, base it off of a convenient percent, and then get to that percent. Like there's a ton of different ways you can look at this, way too many ways, but I don't want to confuse like half my crowd here. That's not the one. That's not what I'm trying to do. There is one more trick that I will show you before we get into the timed practice that we have below right here. All right. So we get some time practice about to happen right now, but going into this one here, 30% of 4,800. So some of y'all have been to my other percent classes where I showed you guys some of the mental math tricks to percent. And here's one of them. Everybody, do you remember Evelyn's question earlier in class where Evelyn asked, hey, could we just move the decimal at the very end with everything? And the answer to that question was yes or no, everybody. What was the answer? Can we just move the decimal place at the end? We could. We absolutely could. Let me go ahead and add on to that. I'm going to blow some minds here. So instead of moving the 30% decimal place to make it 0.30, instead of doing that, whenever I'm dealing with bigger numbers, whenever I'm dealing with a number like 4,800, I'm not going to move the percents decimal. No, I can just move the 4,800s decimal. I can just do this. And I can make it 30 times 48. You are absolutely allowed to do that. If you don't believe me, do the math yourself. You'll see exactly what I'm talking about. And so when we have 30% of 4,800, you can write that as 30 times 48. You can also write that as 3 times 480. That's another way you could write it. And again, this is all just to help you with mental math if you are well equipped for that situation, just if you're equipped. And so if we do the math here, the answer is going to be what, everybody? 1,440 will be the answer there. And I think I saw a question that I just missed there. Let me go and address that question. I got you. Jose asks, can you do that on anyone though? Yeah, exactly. Yeah. Yeah. You can move the decimal places of the other number if you wanted to. Because remember how Evelyn showed was, at the end, you're moving those decimal places back anyway. So if you see a convenient way to apply it early, do it. If not, that's fine. It's fine. It's fine. It's fine. So again, the normal way, let me just show the normal way. The normal way would have been, hey, put 0.30, whoops, put 0.30. And then we would just do 4,800 times 0.3. And then we would do our thing. And we would end up getting something to the effect of 14400 right there. And then we take that decimal, put it back for 1,440. But again, another way could simply be, hey, I can just move the decimal place once with the decimal, once with the number to make a total of 2 decimal movements. And you can end up getting 3 times 480, which arguably, that's probably the easiest thing that you'll do. Not the 30 times 48, not that one over there. It's probably going to be this one. Probably going to be that one. But again, a bunch of different ways to take care of it. So let me zoom on out so you can see the whole picture again. And I'm going to remind myself how many we got. 4. Okay, cool. So in this next slide here, I'm going to give you guys some timed practice, all right? And so we're doing that in the first place, the fastest way. Oh, yeah, Joshua. There are going to be, so what I want to train you guys for is to recognize these convenient situations and apply your mental math skills. That's what I want. Like being able to see a situation and going into your tool belt and finding the right one to use. So with that said, we're going to go ahead and move forward here. One more time, finding percents of numbers. Then we're going to introduce working backwards, and we're just going to be drilling. So we have 4 problems coming up. I'm going to give you 2 minutes. Let's see what you got. 3, 2, 1. Let's say it's the ASVAB gang. Let's go. 2 minutes. This is about. So here we go, man. 13% of 138 inches. Everybody, is there any convenience here that we might want to explore, or do you feel like yo, just multiply this straight up and do it fast. Which way do you guys feel like? Multiply fast or look for convenience? So we got 2 multiply fast, 3 multiply fast, multiply or look for convenience, multiply fast, and I agree. I absolutely agree, because 13% would be 10%, and then 3 1%. If I break it down in my head like that, that's not convenient. That's literally 4 different things. No, I'm dealing with 13%, 2 digits. That's still faster than dealing with all that crap. So let's get to it quick here. 13%. Everybody write it in decimal form. 13% is what in decimal form? Quick, go. That's right, 0.13. That's right. Multiply by 138. And so what we're going to do here is do our math and get it done. So 138 multiplied by 0.13. And so before we even begin, everybody, how many decimal places are we going to move back? How many decimal places are we going to move back at the end? 2. Correct. These are things that you want to keep in the back of your mind while you work. Let's get to it. So 8 times 3, 24. 3 times 3, that's 9. That's 9. Plus 2 is 11. Then here, 1 times 3, that's going to be 3. Bring that 1, that's going to be a 4. Great. Now, up next, we're going to go ahead and drop down to the next digit, which means we are going to go ahead and place a 0. 8 times 1. Oh, all times 1. Going to be pretty easy. 3 times 1 is 3. 1 times 1 is 1. Feeling pretty good about that. Next, 4 plus 0 is 4. 1 plus 8 is 9. 4 plus 3 is 7. 1 plus nothing is 1. We already said it before. We're moving those decimal places over once, twice, once, twice. Answer is 17.94. 17.94. My pen's messing up right now. There we go. Cool. Booyah. So who felt pretty good about that one? Who felt like, yo, I mashed that one. I knew exactly what to do. You know, I may have had to like, multiply that wrong, but you still went at it like you knew exactly what to do. That is what that true confidence is going to look like on test day. That right there. That's what we need to strive for. We're working forward right now. In a couple of moments, we'll talk about working backwards. But boom, there it is. Straight up multiply. 99% of $150. Everybody who looked for a convenience, who did it fast and multiply? Which way did you go? Multiply fast or look for a convenience? Multiply fast or look for a convenience? How did we do it? All right, see everybody here saying multiply fast, multiply fast, multiply fast. Did y'all get $148.50? Did y'all get that? Is that what y'all got? 148.50. Got some yeses, got some nos, got the majority yeses. All right, so I'm gonna do it the regular straight up way. And then I'm gonna show you convenience to see if anybody's gonna just smack their head. Let me see. So the fast way, watch this. If I do 99%, everybody turn that into a decimal. 99% is gonna be what? 0.99, correct. All right. So only thing worse than multiplying by a 2-digit number is if they're both 9s, because 9s are going to create big numbers when you do it. But let me just show you how we can get this done, man. So here we go. 150 multiplied by 0.99. Follow along. 0 times 9, 0. 5 times 9, 45. Carry the 4. Then we're going to have 1 times 9, which is going to be 9. Bring the 4 is 13. Next, I'll go ahead and drop a 0. Let me actually just write that in red so you know I'm working on that second row now. So then we have 0 times 9. That's going to be 0. 5 times 9, 45. Then we're going to have 1 times 9. 9 plus the 4 is 13. So far, I don't think I made any mistakes. So now we're good to go. 0 plus 0 is 0. 5, 8, 4, and 1. We move the decimal place over 2 times. So we'll bring it back 2 times. So what we correct, everybody, is $148.50. Is that the correct answer? Bang, there we go. So it looks like a couple of us here are sitting pretty, got 2 for 2. But let me show you a real convenient way. Let me show you this. So everybody, isn't 99%, isn't it just 1% away from 100%? Isn't 99% just 1% away? Isn't that true, right? All right. So anybody here already have an idea of where I'm going? Who here knows what I'm about to do? Yeah. Watch this. Everybody, ain't 1% pretty easy to find? Ain't 1% pretty easy? What is 1% of 150, everybody? What is 1% of 150? What is that going to be? What is 1% of $150? That's dividing by 100. That's right, Bruno. And if we're dividing 150 by 100, ain't that the same as just moving the decimal place over 2 times? So everybody, what's 150 divided by 100? Go. 1.5, Karen. Ashley says 1.5. Eduardo, 1.5. Yeah, 1.5. If I find 1% of $150, that's going to be $1.50. That is 1%. Again, 1%, that convenient little table that we had there, divide by 100. To divide by 100, just move that decimal place over. We're good. But everybody, answer me this. Because we're trying to go from the original amount, that 100%, down to 99%, doesn't that mean that we can subtract 1%? Would that be fair to say? Yes or no? Is that fair if we just subtract 1%? Right. It would be convenient, right? If we are going from 100% to 99, subtract 1%. And what we just found was 1% is $1.50. So everybody, if I took the original 100% and I subtracted $1.50, which is going to be 1%, don't I end up getting 99%? Don't I end up getting 99%? And so watch this. If I take 150, take away $1, that's 149. Take away 50 cents, 148 and 50 cents. You can get this problem done in 5 seconds in your head. You can do a problem like this in 5 seconds in your head. Yes or no, or wow. Give me your reaction. Yes, if it makes sense. Wow, if you were like, wow, I could have done that. Go ahead. I got a bruh in there too. So again, these are the types of problems over here that you're going to see on the AR and MK. They're going to bet on you going the long way. They're going to bet that you're going to do this. That you're going to be like, oh, I know how to do percents. I'm going to go ahead and just do 0.99 multiply by 150. But the thing is, they're betting on that. If you knew these conveniences, you could be like, yo, I can find 1%, subtract it. 1% is easy. Move the decimal place over and get it after it. And that's it. So these are the conveniences that I really want to show. So let me go ahead and give you the answers to these two, and we're moving right along. So 23% of 84, nothing to do here. We're just going to go straight into it. So 84 multiplied by 0.23, and we're getting after it. So 4 times 3, 12. 8 times 3, 24, plus the 1, 25. Bring a 0 down, next row. 4 times 2, that's going to be 8. 8 times 2, 16. Add these together, 2, 3, 9, 1. Bring those decimal places back, 1, 2, 1, 2. We have ourselves 19.32. Who's feeling good about that one? Yeah, no real mental math to do with that one. No real mental math. That one's just straight up calculate, do it fast. Do it fast, do it fast. Perfect. I'm glad. Now let's go to the last one here. 55% of 90. Here we can use a convenience, but I'm going to do it the straight up way first and then work with the convenient way after. So let's get after it. If we're doing it the fast way, if we're trying to get after it as fast as possible, I'm just going to go ahead, move the decimal place over, and I'm just going to do 90 times 0.55. To work at it quickly, here we go. 0 times 5, that's going to be 0. 9 times 5, 45. If I do again, next row, bring the 0. 0 times 5 is 0. 9 times 5, 45. To work at it quickly. And if you notice, like working at this quickly is pretty fast. And so boom, 0, 5, 9, and 4. Bam, 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 bam. And we got ourselves 49.50. We got ourselves 49.50. So those are all 4 answers there. So I'll let you see that real quick. But I'm going to show you a nice convenient way to do the 55% of 90 pretty quickly. So everybody, 50% is the same as dividing by what? 50% is the same as dividing by what? Same as dividing by 2. Exactly. Everybody, what is half of 90? Go. Right on, right on, right on. So if I'm thinking about this in an alternate way, I can think about this as 50% and 5%. 50% would end up being 45. 5% is just divide by 10 from 50. So that would be 4.5. And again, this is a slightly more advanced way to think about it. So if this is confusing you, just go blah, 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 unless you really want to try to like follow along. But for my folks out here that want to learn these more advanced techniques, for sure, try this, Mikhail. I love it. And so when you have 45 plus 4.5, bring those together, and that'll end up giving you 49.5. Again, if you wanted to use these convenient mental math little tricks, you could think about it like that. So Evelyn, whenever you're multiplying, whenever you're finding the percent of a number, always moving the decimal to the left to make it a decimal. And if you're going from a decimal back to a percent, you move it to the right. Yeah, Jose, for sure. Like so many numbers, absolutely. So take a picture here if you'd like to go ahead and see this there. And what we're going to do next is we're going to take a look at working backwards, get some practice mixed up, and then we're getting to it. Evelyn, about what? This right here? Oh, gotcha. So again, when you are multiplying by a number to get the result, whenever you look, easy as this. Whenever you start with a percent, you're moving the decimal 2 places to the left. If you have a percent, you're moving the decimal 2 places to the left. If you're trying to find the percent, at the end, you're moving it to the right. So if you start with a percent, move it to the left. And if you're going to try to find the percent, move it to the right. Like to find the actual percent number. So we're going to do that right now, working backwards. We're going to do that right now. I got you. And it's always twice. That's right, Bruna. Because we're dealing with 100. And so hopefully I gave you all a chance to screenshot that right there. Christian, go ahead. I got you, boss.
Do they have questions on the ASVAB like what would be 3.9% of 24 or something like that?
Absolutely. That could absolutely be a question. Yeah.
Yeah. Okay.
Yeah. And so if you have 3.9%, just stick to the rules.
Same
Move
thing.
the decimal to the left 2 times. So you'll have 0.039.
Okay, cool.
Yeah, just stick to the rules and you're fine for sure. So again, as a reminder, you can work forward or backwards. So we're getting back into this. Today, we're going to be focusing heavily on this, this method here. There is another method that I already have a recording in the course library for. So if you wanted to check this one out, I already do have a 2-hour recording for that. But again, long story short, everybody, if you're moving forward to find the percent of a number, to find the result, what it would be, forward is multiplying, boom. If you're trying to work backwards to find the original amount, what you started with, you're dividing. You're doing the opposite. You are dividing. And so I want to make sure that one more time, anybody here who came in late, I'll give you 5 more seconds to take a screenshot of this because I'm diving right in. I'm diving straight into the practice. 3, 2, and 1. All right. So here we go. So again, this is one of the things that we might be asked to do. Finding the percent. So here's an example that, again, could very well easily be on the ASVAB. Of those 16 questions in the computer adaptive, those beginning questions are going to be fairly straightforward. And you could see something as easy as this, where they could say, hey, 3 is what percent of 60? So 3 is what percent of 60? So the way that we're going to do this is simply the following way. Everybody, we're asked to find the percent. So I'm going to go ahead and highlight that right over here. What percent? Everybody, look at this. Result divided by the original, that's the same thing as the part over 100. Because remember, everybody, original, what you have to begin with, is that not 100%? Is that not the starting amount? Right? And so the original locks in with 100%. They're the same. And that result, that piece that you have, is related to the part. So everybody, let me ask you a fairly simple question. If my goal was to get that percent by itself, that part percent by itself, what would I multiply by on both sides to get it by itself? Bruno takes a guess with a question mark saying 100. Anybody want to follow up on that? Anybody agree or disagree? Anybody timid here? Yeah, it's going to be 100. We're going to multiply by 100 on both sides for sure. And so look at the rule here. Everybody write it down. So to find the percent, you're going to divide the part by the whole right here, divide the result by the original, and then multiply by 100. Write that down and you'll be fine. Here's the example. 3 is what percent of 60? What we would do is we would say, hey, 3, and let me actually just show you here. Everybody, write this as an equation. 3, everybody, the word is translates to what? The word is translates to what in math? Is translates to equals. Is translates to equals. 5 is, or like 2 plus 2 is 4. 2 plus 2 equals 4. So that's going to be equals. Then we're looking for the percent. All right, cool. I'm looking for that percent. So I'll just go ahead and say P percent, whatever. And then of, everybody, the word of means what? Multiply, that's right, multiply. And then the 60 means what? 60. It's just 60. So what we have here, to get the percent by itself, what I'm going to do is I'm just going to go ahead and divide by 60 on both sides. So all I'm doing here is I'm explaining what this means. All this mumbo jumbo, this shortcut, I want to make sure you understand what's going on. If I write this out in the pure form, 3 is 3 equals what percent of 60? All I did was translate this English into math, and to get it by itself, I would have to divide by 60 on both sides. And so that's going to cancel out right there. And so we would perform 3 divided by 60. Let's go ahead and take care of business, everybody. 3 divided by 60. Let's go ahead and try that out here. So everybody, can 60 go into 3? Yes or no? Can 60 go into 3? No. So we'll have to actually include some decimal places here. And if you're not familiar with this, I got you. What we would end up doing would just be putting a decimal place and then placing some zeros here just in case. So everybody, does 60 go into 30? Not quite, right? So we'll just put another 0 there. That's fine. But does 60 go into 300? Does 60 go into 300 though? It does. How many times does 60 go into 300? Not 3, not 2, 5 times. iPhone shout out, Evelyn, Cariatu. Yep, it's going to be 5 times. It's going to be 5 times because 60 times 5 is going to be 300. 60 times 5 is 300. So 60 goes into 300 5 times. So when we subtract that, all good. And we have 0.05. So watch this, everybody. When we find that, when we do the 3 divided by the 60, the part divided by the whole, we end up getting 0.05. Everybody, is that in percent form? Is that in percent form? Got 2 no's so far, got 3, 4, and the floodgates open. Nope, unfortunately, it is not in percent mode. So everybody, look, a lot of math is really just going to be working backwards. A lot of it really is. So everybody, talk to me. The forward way to go from a percent to a decimal, we move the decimal 2 times to the what? To go from percent to decimal, we move the decimal 2 times to the... If I'm going from percent to a decimal, not right, it's to the left. Remember, everybody, if I'm going like, let's say I have 65%, if I'm going to a decimal, I would move it over 2 times, 1, 2, to make 0.65. So then if we're going from a decimal back to a percent, instead of going 2 times to the left, we're going to go 2 times to the right. Yep, 2 times to the right. Right there. So again, let me write this down for everybody to make sure that we have it. So let me write this down. Let me find some good space for us. So let me go ahead and do it right over here. So percent to decimal, it's going to be 2 times to the left. And if we're doing from decimal back to a percent, it's going to be 2 times to the right. Got to make sure we have that down, all right? Got to make sure we have that down. So again, percent to decimal, 2 times to the left, decimal to percent, 2 times to the right. So I'll zoom in for anybody here who's using their phone. I got you. A part of people using their phones. I got you. Alex, you might want to turn your phone horizontally. That might make it easier for you. All right. So hopefully we got that down. So again, percent to decimal, 2 times to the left, decimal to percent, 2 times to the right. So with that said, my party people, the answer here is not going to be 0.05 because this is in decimal form. This is in decimal form. So everybody remind me, how do I go from here to a percent? That's right, 2 times to the right, 2 times to the right. So we'll go once, twice, and so we should have 5%. That should be our answer. So that's one of the biggest things there. I know it sounds like, oh, it's just a little simple rule, but we're actually going to have to really pay attention to that right there. To go from a decimal to a percent, you move it to the right. Hey, right on, Sal. Thanks for letting me know, man. But yeah, move it to the right twice. And so that's why the answer here would be 5%. That'd be 5%. So I want to move into here, this next set, or not next set, but this next thing here, finding the original number. So here, what 20% of what is 50? First, I need to coach you on how to actually know what the hell you're looking at, right? And then 2, I'm going to coach you through the solution process. So watch this. The easiest way to do this to figure out whether you're moving forward or backward is really going to be, okay, what is this saying? What is this saying? So everybody, watch this. Watch this. Everybody, 20%. So I'll just go ahead and say 0.20. Everyone, the word of means what? The word of means what? Multiply, right? Yep. And then when they say what, isn't that just like a variable, like a letter, right? I'll just go ahead and say, some number. And then the word is translates to equals. Exactly. And then 50. Boom. So look at this. Everybody, look at how we can set ourselves up. We just wrote an equation out of that. 20% when you convert it to a decimal is 0.20. Of means multiply. What means some number. So I'm just going to write number. Is, that's the same thing as saying equals. And then 50 is, well, just 50. And so in all, what we have here is 0.20 times some number is going to equal 50. Everybody, are we working forward or working backwards here? Are we trying to find the result or trying to find the original number? Mario says backwards. Marquette says forward. I see Gene says backwards. Mariah says backwards. We're trying to find the original number. We are working backwards. We are working backwards. We have the result right here. It's on the other side of the equal sign. It's by itself. We have the result. We got the result right there. We're looking for the original. And so in my notes, remember my party people, remember, in my notes right here, I tell you, if you're working forward, you're multiplying because you have the original and the percent moving forward. But here, you're working backward because you're given the results and you gotta find the original number. So this is why, again, paying attention to those little details in these notes, like that's really what's going to spell confidence. So we have that going on there. We got 0.20 times that number equals 50. Everybody, what do we have to do to both sides of this equation here to solve this? We already said it. To work backwards, we divide. Exactly. And so all we're doing here is 50. So again, we're going to divide both sides by that 0.20. To get rid of it on the left side. So let me just erase this here. To get rid of it on the left side and to get our original number. So our original number is going to be equal to 50 divided by 0.20. That's going to be our answer there. That's going to be our answer. And does anybody here want a pretty easy way to kind of do this decimal? Like, well, first of all, does anybody here get a little nervous when you're dividing by decimals? Anybody get nervous dividing by decimals? Doesn't that make anybody feel a little awkward? I mean, for me, honestly, sometimes I'm looking at it like, I don't want to do this, right? I don't want to do this. I'm not lazy. I'm just a little apprehensive. I mean, it's okay. It's super okay, super okay. But everybody, let me show you another trick to make your life easier. Here we go. This is like Willy Wonka and the Math Factory. So what you can do here, honestly, nice, true, simple, and short. Watch this. Everybody, when it comes to fractions, isn't it true that whatever you do to the top, you do to the bottom? Right? Isn't that true? I'm just playing off of a fact here, right? Whenever we are dealing with fractions, whatever you do to the top, you must do to the bottom. Whatever you do to the bottom, you must do to the top. So what if I got a little brave here and just said, all right, I'm going to move this decimal place over one time, move this decimal place over one time to make it the same thing as 500 divided by 2. Would that make anybody feel a little more at ease? Would that make anybody feel a little more at ease? I think it would. I think it would. Everybody, what's 500 divided by 2? And we're done. 250. Anybody here sitting here like, what the hell did he just do? I like it, but I need to know what the hell he just did. Anybody here feeling that way? Yeah, that happens a lot in these classes. So let me explain here. Everybody, if I am moving the decimal place to the left, I'm dividing by 10. Again, then divide by 10 again. So again, when we divide by 100, that's by turning that percent to a decimal. We are dividing by 100, so we move the decimal place over 2 times because it's 100. If I multiply by 10, I'm moving the decimal place over to the right for every 10. So if I'm dividing by 100, that's dividing by 10 twice. So that's why you see 2 decimal places to the left. If I multiply by 10, move the decimal place to the right. Multiply by 10, move the decimal to the right. So technically speaking, technically speaking, all I've done is multiply the top and the bottom by 10 so I can get rid of the decimal and give myself an easier time. That's the reason why that works. Because if I move the decimal place over to the right one time, both top and bottom, all I'm doing is multiplying the top and the bottom by 10. Does that make a little more sense to anybody as to why that actually works? And Mikhail, I saw your comment there. Cool. I'll go ahead and do it the original way too. And again, be honest, everybody. Mikhail, thanks for being honest. Oh, yeah, you need more practice for sure. Yeah, more practice for sure. So if we go ahead and get this done here, what it's going to look like is in this way. It'll look like this. 0.20. I'll just do 0.2 dividing into 50. So the way that this is going to get done is basically like this. When it comes to multiplying decimals, you basically bring them back at the end and you move to the left. When it comes to dividing decimals, at the end, you move it to the right. So watch this. Everybody, 2 goes into 5 how many times? That's going to be twice. Subtract the 4. You have 1 left over. Bring the 0 down. Watch this. 2 goes into 10. How many times? That's going to be 5. Subtract the 10. That's going to be 0. So we have 25. So again, when you're multiplying decimals, you bring those decimals back at the end and you keep moving to the left. When you're dividing by decimals, you do the opposite. You move to the right, however many decimals. So right here, I moved to the right 1 time. That's why the answer would still be 250. Mikhail, does that help you out a little bit there? Cool. So again, the simple way to do it, if you want to do it straightforward, dividing decimals, move the decimal to the right at the end. Move the decimals to the right at the end. But there's your answer there. It's going to be 250. I want to give you guys a chance to get some warm-up problems in, and I'm hoping to get a couple of these drill set questions in as well. So here we go. Take a screenshot there. Give you 5 quick seconds there. Let's go ahead and start working backwards now. 3, 2, 1. Let's try it out. So I'm going to try to keep all 3 problems in view. So that way, if you want to work ahead, you can. Right there. And so watch this. 1% of what is 150? Everybody, for this first one here, are we working forward or working backwards? Right, we're working backwards. Because remember, you look at the word is, we have a number for is. It says 1% of what is 150. That's the result. We're trying to find the original number. So everybody, we know we're working backwards. What do we always want to do when we're working backwards? Is that multiply or divide? Right, that's going to be divide. And so what we're going to do now is we're going to take care of business by dividing. We're going to divide that 150 by 1%. So here we go. Backwards. And what we're going to do here is we're going to take 150. We're going to divide it by 1%. But we can't just write 1%, everybody. We got to convert that to a decimal. So everybody, we're going to have 150 divided by what? Devin, nice and quick there. I love it. Mikhail, Alex, great job, guys. 0.01. And so from there, what we're going to do is do our thing. 0.01 divided into 150. Everybody, how many times does 1 go into 1? Well, once. How many times does 1 go into 5? 5. How many times does 1 go into 0? 0. And we're done. But the fact of the matter is, we have to move that decimal place over once, twice. Once, twice. So the answer would end up being 15,000. That's what the answer would end up being. And so let me show you the other way as well. Yeah, Marquette. Yeah, the easy way here. Again, if I'm dividing right here, so let me go ahead and highlight the area I'm working on here. If I'm dividing by 0.01, I'm looking at that like, yo, I would love to divide by 1. And what I would do is do this. If I wanted to move this decimal place over once, twice, I would have to move it from over here once, twice. And so that would turn the problem into 15,000 divided by 1, which is just going to be 15,000. So do you see what I'm saying there? You see what I'm saying there? We can either move the decimal places right there conveniently. We can do it with a long division. Either way is going to work out just fine. Either way. But when you're dividing by a decimal, you're not bringing it to the left at the end. You're bringing it to the right at the end. Want to make sure we know that for sure. Again, when we're multiplying decimals, we're moving to the left. When we're dividing decimals, we move back to the right. Yes or no? Does that make sense for anybody? Cool. And so, Eric, I think you had a question first. Eric, I'll take yours first. And then, Jose, I will take yours second. So, Eric, give it mic. Go ahead.
Hey, Coach. I got a quick question. There, I learned in like I follow your videos, everything for percentage. I noticed if like 1% of 15, you could do just multiply 15 times 1, you get the same answer? Yes or no?
In this case, 1% of what is 150?
Yeah.
I think you might be talking about a different example there.
No, the same question. Right now, I'm just driving that thing.
Oh, so no, here that wouldn't work. Multiplying the 1% by 150 would not work. It may look like it might work, but it wouldn't, because to go back to 100%, you're just multiplying by 100. So what I want you to do is hold out that thought. I want to show you these other two problems, and I want you to basically answer that question for yourself to see if that pattern still works. All right?
Okay.
Let's try that out. And then Jose, what's up, boss?
Coach, I don't know if this works. I was just thinking about that. I heard that this is what I've done, but sometimes I don't get it right. There's another way. First you divide and then you multiply. Like, would that be another way?
That's technically what we did, because we turned the 1% into 0.01 by dividing by 100.
Yeah, and then you multiply.
And then we ended up, kind of in that way. But honestly, if you think about it like this, look, 1% is to 100% times 100. That's exactly what we did. We literally just multiplied by 100. That's literally what we did. And I want to get through these other two examples here to show you what's up here. So 24 tons is 96% of what? So everybody, working forward or backwards? What are we doing? $24 tons is, you already know right there, from right there, you know we have the result. So if we already have the result, we're working backwards, right? If we already have the result, we are working backwards. And so with that said, boom, what we need to do here is work backwards, divide by that 96% on both sides. And so that's exactly what we're going to do. It's exactly what we're going to do. So here we go. We're going to divide both sides by that 0.96. And here we just can't be afraid here. We just have to go at it, get to it. Yeah, it's going to suck. Dividing by 96. Yeah, I know, but it's fine. It's fine. So we're going to have 24 divided by 0.96, which will look like this. And so with that said, let's go ahead and get to it. So does 96 go into 2? Yes or no? Go quick. No, it does not. No, it does not. So we're going to mark a 0 right there. Everybody, does 96 go into 24? Help me out. Nope, that's not going to happen either. So we got a decimal place that we're going to bring down right there. Now we're going to bring down our zeros here. How many times does 96 go into 24, everybody? How many times is that going to be? How many times is 96 going to 20 or 240, excuse me, 240? Twice, exactly. Because we can do some math real quick here. 96 multiplied by 2, 6 times 2. That's going to give us 12. And then 9 times 2, 18. 18 plus 1 is 19. So we have 192 right there. And so boom, that'll be 2 times. Minus 192. Subtract there. All right, I can't really subtract these, so I got to borrow now. And this is where things get a little funky, but you got to stick with it. So boom, 3 and 10. 10 minus 2, that's going to give me 8. And then I'm going to bring that 2 down for a 1 to make it 13. Everybody, 13 minus 9 gives me 13 minus 9 gives me that 4. That's correct. So we got that 4, 8. So then we're going to bring another 0 in. And then we're going to drop that down. Anybody want to guess in terms of how many times 96 goes into 480? Not 4. Because if you think about it, if 192 is pretty close to 200, 200 times 2, because if 192 is 2, double it to get 4, that's still nowhere near 480. We can try to guess 5. Yeah. Take a guess at 5. 5 would be a better guess. And if you do it, 96 times 5, watch this. To multiply by 5 is the same thing as multiplying by 10 and cutting it in half. But I'll go ahead and save that for later. 6 times 5, that's going to give you 30. 9 times 5, 45. Bring the 3, 48. Good guess on our part. That will be a 5 right there. That will be a 480. Anybody thankful that this wasn't uglier than it is? Because now we have 0.25. Right now, as it stands, we have 0.25. Everybody, what do we need to do now at the end, though? What do we need to do at the end here? Hint, hint. Right there with that decimal. What do we say we need to do when we divide by decimals? Are we moving to the left or to the right this time? When we divide by decimals, we go to the, that's right, there we go. We go to the right, exactly. Great job, guys, great eye. So what we have here is going to be, hey, I move this to the right, 1, 2. I'll take it right here to the right, 1, 2. So the answer will be 25. And that'll be it right there. So with that said, my party people, what's harder, working forward or backwards? Of course, right? Of course. Working backwards, of course, man. And think about it. Solving equations, that's working backwards. A lot of people have trouble with that. When we're talking about other ideas, like when we're doing distance, rate, time problems, when we're not given the distance, or when we're not given the rate, but we got to find the distance, got to work backwards. Those are always harder. Every idea that you got to work backwards with is typically going to be harder. But let's look at this problem right here. This doesn't have to be hard. Everybody think about it like this. Everybody, 32 is 50% of what? Everybody, what's the automatic answer going to be? 5, 4, 3, 2. Anybody? Anybody? Mario, correct. 64. Let me go ahead and show you why. Think about it like this, everybody. If 50% is 32 pounds, well, isn't 100% just double that? 64. That's one way to think about it. Great job, Mario. Great job, man. That is one way to think about it. Because remember, if you're trying to go from 50%, we're working backwards. We're not going from 100 down to 50% divided by 2. No, we're working backwards. We have 50%, and we're trying to go back up to 100. And that's multiplying by 2. So is anybody here starting to see those relationships, those convenient percents, and how we can work backwards with them too? Anybody here starting to see that? Even if it's a little bit, I will take that because we can continue growing from that to give ourselves an easier and easier and easier time. Absolutely. Absolutely.